This is Turner, and I'm going to go through a short video here to help walk you through the notes for section 1.5, which is titled Using Formulas in Geometry. So our goal this section, or our learning target, is to be able to apply formulas for perimeter, area, and circumference. I'm going to go through the video without many pauses, so feel free to pause the video whenever you need to stop, take notes, and then hit play when you're ready to go on. So the first formula that we're going to look at is the perimeter of a rectangle. And really this probably is review for most of you. Sometime in middle school you probably studied rectangles and squares and triangles and circles and looked at some of these formulas for perimeter and area. But we're going to take it just a little bit further in this section. So perimeter of a rectangle. So perimeter, first of all, means the total length around the rectangle. So let me actually clear off some of my screen here. So if you're thinking about the perimeter, think about your, starting at one corner here of the rectangle, and we're just walking all the way around. So it's the total length around. So adding up all four sides. But we can use a little bit about what we know about rectangles, and we're going to study rectangles a lot more in depth later this year. But notice we have these congruent marks. So we have these two longer sides are marked congruent. L stands for length. So the two longer sides, the length, and then you have the two shorter sides. They are also congruent, and the W stands for width. So you have width, two widths are the same length, and then the two lengths are the same length. So instead of adding up all four sides, you can simplify it into a formula and say it's 2 times the length plus 2 times the width. Or you can add the length and width together first and then multiply by 2. So that's the perimeter formula. And then the area of a rectangle is length times width. Okay? All right, moving over to a square. So notice these congruent markings on a square. So even if we didn't know anything about a square, we could see, oh, hey, there's 4 congruent sides. Congruent means same size, same shape. When we're talking about segment length here, we're referring to the same size as being the same length. So each side has a length of S. So the S stands for side. So again, we could think about perimeter and just add up all 4 sides, or we can simplify it. So if we know the length of one side, the perimeter is 4 times that side length. And then the area is the side length squared, or to the second power. All right, so that's rectangles and squares. All right, triangles, moving on here. Inside the kind of square rectangle here, we have the formulas for a triangle. So the first one is perimeter. And there's really nothing kind of fancy or simplified we can do with perimeter. It is simply just A plus B plus C, which is the sum of all 3 side lengths. So side length A plus side length B plus side length C gives you the perimeter of the triangle. Okay. Then area, there are kind of 2 different ways you can think about it. You can think about it as 1/2 times B times H, and the B here stands for base, and the H is the height. So I'm just going to kind of add those in there. So 1/2 base times height, or you can do B times H, or base times height first, and then divide by 2. And one thing to notice in the triangle are the relationships between the B and the H, okay, the base and the height. Notice the height here. This is the segment from a vertex, one of the vertices of the triangle, going down to the base, which is any side of the triangle, forming a right angle. Okay, so the base can be any side. So in this particular triangle, I'll go through that again here. The base here is that bottom side labeled B. Then the height is not necessarily one of the other sides. It could be, but it has to be the length from the vertex of the one of the vertices of the triangle, that length down to the base, forming a right angle. Okay. And over here, you can see there's 3 different kind of scenarios. You may be familiar with the first type of triangle, maybe even the second. Not sure if you've seen any triangle like the third one here, where notice the height is actually drawn outside of the triangle. And remember, we talked about dashed lines in diagrams. It means that, it's a length that's there, but it's not visible. So in respect to a triangle, it's not one of the 3 sides. Instead, it's just this kind of invisible length that we're measuring. Okay. So notice the bottom side is the base on all these triangles. The first one, the height, is actually a side of the triangle. This middle one, you can draw the height in, kind of going in the middle there inside the triangle, and the one on the right, the height is on the outside. But either way, what you're doing is the height is kind of, think of it as like the length from the bottom to the top of the vertex, straight down to the base. All right, so let's look at a couple examples. On your notes, I noticed the directions actually weren't given to you. So this first example, you might want to write in what we're doing. We're going to find the perimeter and area of each figure. So the first one, a rectangle with length of 17 centimeters and width of 5 centimeters. So I would recommend first, let's draw ourselves a diagram. So let's draw a rectangle. Okay, we have 2 shorter sides that are the same, the 2 longer sides. Length, the longer side, is 17 centimeters. The width, or that shorter side, is 15 centimeters. I want you to go ahead and pause this video and see if you can find the perimeter and the area. Okay, so pause. And then when you're ready, hit play and I will walk you through it and you can check your work. All right, so perimeter, I am going to use the formula of 2 times the length, which is 17, plus 2 times the width, which is 5. Okay, 2 times 17 is 34. 2 times 5 is 10. 34 plus 10 equals 44. And we have units, which are centimeters. So the perimeter, or the length all the way around, the distance all the way around all 4 sides, is 44 centimeters. Then when we go to area, we use the formula length times width. So that's just 17 times 5, which is 85. And area is in units squared. So 85 centimeters squared. All right. Moving on to the triangle. We'll kind of do the same thing here. I'll help you kind of get it set up, and then I want you to pause and try it. So we have a triangle with A equals 8, which is one of the sides. B is x plus 1. C is 4x, and the height is 6. So we don't really know what this triangle looks like. We can just kind of sketch any sort of arbitrary triangle here. And I'm going to let my base be the bottom. So B, x plus 1. Doesn't matter which side is A or which side is C. So I'm going to put 8 over on the left, 4x on the right. My height from that top vertex straight down to the base at a right angle, that is a length of 6. So we have our base, x plus 1, our height equals 6. Those are what we need for our area, and then perimeter, just add up the 3 sides. So again, why don't you go ahead and pause, see if you can find the perimeter, see if you can find the area. And then when you're ready, hit play, and I will go through it for you. All right, so the perimeter. A plus B plus C. So add up your three sides. 8 plus 4x plus x plus 1. Now, because we're dealing with variables, we're actually not going to get a number answer. We're going to have x in there. So we just add up our three sides, 8 plus 4x plus x plus 1, and then just simplify the best we can. So we can combine like terms. We can combine 4x and x. And then our constants, we can combine 8 and 1. So we get a perimeter of 5x plus 9. And we don't know the units, so we can just write units. Since we don't know whether it's centimeters or inches or meters or what the unit is. All right, so that's perimeter. All right, area then. Area of a triangle is 1/2 base times height. Base is x plus 1. Height is 6. So we're just plugging in to our formula. And then we simplify. Now I'm going to just rewrite this. I'm going to move the 6 out front because base times height is the same as height times base. Just to maybe make it a little bit easier to see that, hey, we can do 1/2 times 6, which is 3. And then bring down times x plus 1. And then we can distribute the 3. We get the area equals 3x plus 3. Since we don't know units, we can write units squared. So there's the perimeter and area for a triangle. All right, moving on to an application problem. Again, if this is going too fast, you can pause at any time, rewind. This video is yours to go through however you'd like. All right, it says that the Texas Treasures quilt block includes 24 purple triangles. So here over on the right, we have a picture of a particular section here of a quilt, and it's using all these different triangles. We see some squares, so a lot of geometry going on in this quilt. But there's 24 purple triangles. We're given that the base and the height of each triangle are about 3 inches. And we want to find out about how much fabric is used to make the 24 triangles. So when we're talking about the amount of fabric, we're talking about the area, okay? Area is the total kind of surface area, which we'll get into a lot later this year. But area is kind of what's the amount of fabric. So if you're looking at a triangle, it would be areas, all that space inside. All right, so we need to know how much fabric we need for 24 purple triangles. So we're given the base is 3 inches, the height is 3 inches, and we need to find the area. So the area of one triangle, okay, and we can make a little notation like that. Area of a triangle is 1/2 base times height. So plug in 3 for base, 3 for height. 1/2 times 9. And it doesn't matter the order. When you're multiplying 3 numbers, the order really doesn't matter. But I'm going to go 3 times 3 first, and then take half of that, which is 4.5. And this is inches, right? Yeah, so inches squared. So if one triangle is 4.5 square inches, then 24 triangles, okay, so the area of 24 triangles would be just 24 times 4.5, which is 108 inches squared. So, whoops. So that's how much purple fabric you would need. 108 square inches. Now, I don't know much about quilting and fabric, but I do know it's typically sold in square yards. So if you're making that quilt, you might now have to convert that to square yards, but we'll save that for another day. All right, last shape here are circles. So perimeter and area of circles are referred to as circumference, the perimeter of a circle is referred to as the circumference. Area is still area. But circles have a special word for perimeter, and that is called the diameter. The circumference. Okay, so here we have the circumference, which is the distance around a circle. Okay, but in order to find the circumference, we need to know two parts of a circle. We need to know either the diameter or the radius. So let's go through each definition here. So diameter is a segment that passes through the center of a circle and whose endpoints are on the circle. So if you look at the circle on your screen, the one that I just traced, it just traced the diameter. So through the center with the two endpoints on the circle. So if you think of a clock, right, that center in the middle where the two hands meet in the middle, if you went from 9 to 3, okay, connecting, that would be a diameter. Or if you went, you could also have a diameter going top to bottom, right, 12 to 6, etc., etc. The radius is then half of that length. So notice it's just now starting at the center. So one of the ends is on the center, and then it goes out to the circle. All right, so now I think about just have one hand of a clock going from the center up to 12, or from the center going down to 5 or down to 6. Okay, so those are all radii, which is plural of radius. Those are all different radii of a circle. All right, so kind of back to circumference here. The circumference would be if you are traveling around the diameter, tracing around the diameter, it's that total length. So if you had like a string and you wrapped it around a circle and then you laid it out flat on a ruler and measured the length, that's the circumference. So it's, in a way, it's the perimeter of a circle, okay, the distance around a circle. All right, so now if you flip your notes over, we'll look at the formula. So this is where you need to know either the diameter or the radius to be able to find the circumference and the area. So circumference, you can define it as either C equals pi times diameter. Okay, so the D stands for diameter. Or you can define it as C equals 2 pi r, where r is the radius. Okay. And then the area of a circle, A equals pi r squared. R is, again, the radius. Okay. When we are using pi, so the Greek symbol for pi, the Greek letter for pi, is right there, right? Which we can approximate it if we want to estimate it as either 3.14, or if you prefer fractions, or if you want to use a fraction form, it's 22 sevenths, so 22 over 7. There's also a pi button on your calculator, so we can also use that, so you don't have to know and don't have to memorize those decimal or fraction approximations. All right, so let's jump into the example there. So find the area and circumference of the circle. And notice it says express your answer to the nearest tenth. So that means we're going to round using our calculator and in terms of pi. So that might be new to you, but we're going to end up having that pi symbol in our answer. All right, so let's first start with what do we need to know? We need to know either the diameter or the radius. And in our circle diagram here, we are given the radius is 3 centimeters. So now it's just a matter of plugging into our formulas. So if area is pi r squared, 3 is the radius, so plug in 3 for r. Now here's where I'm first going to leave my answer in terms of pi. So 3 squared is 9. So pi times 9. This is if you had something like x times 9, you would rewrite it as 9x. Same thing. I can rewrite this as 9 pi. That's kind of the more standard, acceptable way to write that. So 9 pi, and then our units, centimeters squared. So that is when we say in terms of pi, that's what we mean. Leave pi in your answer. And when you're multiplying, just think of it like a variable, right? If we had x times 3 squared, you would square the 3 and get 9. So x times 9, and then, like I said, you'd rewrite it 9x, right? Notice the x is just coming along for the ride. Kind of the same concept, right? The same idea where pi is just in your formula, and it's going to be in your answer. But then if you want to now approximate it and round to the nearest tenth, you can either do 9 times 3.14, or you can hit the pi button in your calculator and you get about 28.3 centimeters squared. So that would be our approximation. So just be careful of what it's asking. If it doesn't specify, then you probably can do whatever you want. The pi, the approximation, or in terms of pi, if it does say one or the other or both, the best answer though is just leaving pi in your answer. That's more of an exact answer. All right, last example here. This one now we're given the area is 64 pi. And we have to kind of work backwards here to find the radius and then find the circumference, okay? And notice this one does say express your answer in terms of pi where necessary. So let's think about our area formula, right? Area is pi r squared. So this time we know the area. So on the left side, I'm going to plug in 64 pi. And then on the right side, leave it as pi r squared. And here I need to solve for r. So we're going to have to use some of our algebra skills of solving equations to get r by itself. So I notice that pi is out front. Remember, that's just a number, right? Times 3.14. It's multiplication. So to undo multiplication, we divide. So I'm going to divide both sides by pi. And it ends up canceling out on both sides. Okay. Now, if you're not used to working with pi like this, we're going to be doing a lot of this year. But, remember, it's just a number. But also think of it in terms of when you're using it in equations and solving equations, think of it like a variable, right? So notice how when you have pi divided by pi, just like if you have x over x, cancels out, reduces to 1. Same thing here. So over on the left, pi over pi cancels out. We're just left with 64 on the left. Bring down r squared on the right. And then to get r by itself, right, still focused on what we're doing here, we're trying to find the radius. We take the square root of both sides because a square root undoes that square, right, undoes the raising of the r to the second power, and you're left with just r. And then the square root of 64 is 8. So the radius is 8, and we don't have any units, right? So we'll just say units. Okay, so there's one answer. And then don't forget, we also have to find the circumference. So now we jump to our circumference formula, which is either pi times diameter, or notice on all these we're given the radius, which is fine. So then it's 2 times pi times the radius, which we just found as 8. Okay, the 2 times 8, 16, pi comes down, and then units, so 16 pi. All right, so that kind of sums up section 1.5. So again, if this went too fast, if you need to go back, you need to pause. But the main thing here to focus on are some of these formulas. So rectangle, square, we looked at triangle formula. And then we looked at a little bit of basics about circles as far as the diameter, radius, and then the circumference and the area formulas. All right. So what you can do on your own now is the 1-5 worksheet that I passed out last class. And also just want to kind of give you a heads up. So next week on Wednesday, we will go over 1-5. We're also going to look at 1-6. And then next Friday, you're going to have a quiz on 1-4 to 1-6. And 1-6 is a section, actually a little bit of some algebra involved. I mean, looking at some points now and segments on a coordinate plane, looking at midpoints again, a little bit more in depth, but now looking at it on a coordinate plane. So 1-4 was what we did in class, on Wednesday with the pairs of angles. 1-5 is what we talked about in this video. 1-6 we'll look at next Wednesday, and then Friday we'll review and have another short little quiz. All right, I'll see you guys in class next week.